Okay, I just want to start just by... Alright, I'm just going to start just by looking at things in index form when you have negative and fractional indices. Okay, so just first of all, if you have anything over the fraction like 1 over x to the n, then when you bring that up to the top, the sign of the indice will change. So that n there will become negative. So that's actually equal to x to the minus n. So if you have 5 over x to the 4, then that would be 5, and you bring it up to the top, x to the minus 4. If you have anything with, so that's a negative indice, but like with a fractional indice, so let's just say the nth root of x to the m, let's write that a bit better, so the nth root of x to the m. So to put it in index form, you put the n on the bottom and the m on the top. And just a little way to remember this, if you look at that, you might notice that the n is at the outside of this thing. So we call that like at the door. All right, so we call this is like a house, all right, and the n is at the door. So a way to remember it is at the door is on the floor. So at the door is on the floor. So that's that one there. Okay, and the other thing, just to do with the m, the m's here. Okay, so one way to remember that is what's on top stays on top. And just another little way of remembering this, okay, if you have the nth root of x to the m, it's m on n with the x there. Do you notice that this here, that n there, that is your root? That's your root. Okay, and your root, this is like the flower, and the root is at the bottom of the fraction. So this is the like flower power, and this here is your root because it's at the bottom of the flower, and that's the root there. So the root stays on the bottom of the flower. Okay, so let's look at differentiation. All right, so just looking at this here, you can't differentiate that until you put it into index form. So it becomes 5x to the minus 3. Okay, and then when you go to differentiate this, it's 5 times minus 3, because the minus 3 comes down, x to the minus 3 minus 1. And it is better to write this like this and then simplify that indice, because sometimes it's easy to make mistakes with negatives. So that's minus 15x to the minus 4, which is minus 15 over x to the 4. Now, that's all good. If we look at this one, I want you to think of this as 4 on 3 times 1 on x to the 5. So you don't bring that 3 up the top, because it's not part of the fraction. And then when you bring that up to the top, it's x to the minus 5. Okay, so 3's down the bottom, and the 4's up the top. So let's differentiate this. Now, it's probably a good idea sometimes just to take that x to the minus 1 and just put it over 1 so you realise that it's on top. Okay, so now when I differentiate this, you get 4 on 3 times minus 5, and notice I've kept it on the top, x to the minus 5 minus 1. So the 4 and the minus 5 are both on top, so you times those two numbers, and the 3 and the 1 are on the bottom. So you just times the top, so you get minus 20, and times the bottom, so 3 1s are 3. and then you get x to the power of minus 6. Now I could leave it like that, but it's a good habit just to get rid of the negative indice. So if you bring it down to the bottom, it'll be x to the power of 6. Okay, so with the fractional indices, so we've got the roots, we've got to get it into index form first. So this is like the square root. The square root's got a 2 there that's not really there and a 1 there. So if it was the nth root of x to the m, it's the n's at the door, so that's on the floor, and m, what's on top stays on top, so the m's on the top. So if we apply this here, this would be x, the 1 will stay on top, and the 2 will end up on the bottom. So now when I go ahead and I differentiate that, but half will come down the front times, now make sure you write the x on the top. You could even put it as x over 1. That's half to the power of minus 1. So that's 1 on 2, x on 1 to the minus a half. So times the tops, that means you get 1x to the minus a half on 2. Now I'm just going to make an effort just to bring that down to the bottom to make it a positive indice. And then x to the power of a half is the square root of x to the 1. So the 2 really goes there. But you don't actually really need to write it, and you don't really need to write the 1. Okay, so let's now look at part B. The fifth root of x to the 4. The fifth just is at the door, so the 5 is on the floor, and the 4's there. What's on top stays on top. So when you differentiate this, this would be 4 and 5 times x to the 4 on 5 minus 1, which is 4 on 5 times x. 4 on 5 minus 1 is minus 1 on 5. Make sure you realise that's on the top, so put it over 1. And then it's 4 on 5, and I'm going to bring that down to the bottom, x to the 1 on 5, which equals 4 on 5, and it will be the fifth root of x. Okay, now finally, see, 3 on x, the fourth root of x to the 5, so it's 3. We have to put it in index form first. So it's going to be 5 is on top, 4's on the bottom, because what's at the door will end up on the floor, and what's on top, which is the 5, stays on top. Okay, so going back to this, bring it up to the top because it's still not in index form, so that'll be x to the minus 5 on 4. Okay, so we go 3 times minus 5 on 4. The 3, make it over 1, so we know it's on top. X, now that's going to be minus 5 on 4 minus 1. So 3 times 5 is minus 15. 1 times 4 is 4. X to the, now minus 5 on 4 minus 1. It's minus 1 1/4 minus 1, which is minus 2 1/4. 2 4s are 8. Plus 1 is 9, because it's best to write this as an improper fraction, because then you know what part's the root and what part's the power. So you get minus 15 on 4, and make that over 1. So if you bring that now down to the bottom, that would be x to the 9 on 4. And then if I want to write it in root form, it's minus 15 on 4. It's 9 on 4, so it's the fourth root of x to the power of 9. That's your answer.